HVAC 360 is brought to you today by Toes Out Construction Sandals. Do your feet ever get hot on the job site in the summertime? Ever wish you could just set your piggies free to breathe the fresh air like you do at the beach, pool, or a picnic? Well, your wait is over. These poor excuses for construction footwear do come in a variety of sizes and styles for whatever fits your mood. Of course, they also come with a free OSHA citation certificate already filled out. And don't forget, we also include a replacement set of piggies too, in case a few of those piggies go wee right to the hospital. Who needs a perfect incident report anyway? Get yours today. Your toes will thank you, even though your boss won't. Hey, welcome back. Matt Nelson here, your host for HVAC 360, helping you be the best and the brightest in the field of HVAC. Each week, I'm either sharing information and lessons learned from the field or talking with industry experts, but I don't stop there. I want to encourage you to double down on your weekly helping of HVAC knowledge by hopping on over to HVAC360.com and join my growing community of people just like you. I am also happy to say that I've started up the membership site, so if you're interested in that, go take a look over at HVAC360.com. So, what's on the docket this week? This week, I wanted to take another seminar summary from the 2018 Houston ASHRAE conference that I had the virtual conference ticket for. And that's good for another 6 months here, so I thought I'd dive into something that looked interesting to me. This one was called a Documented HVAC System Efficiency Deterioration. So I'm like, okay, evaluating existing systems, that seems like it's right up my alley. And so what was it talking about? This actually was centered around ASHRAE's proposed standard, that is 221, which is, and here's the actual name for it, test method to field measure and score the cooling and heating performance of installed unitary HVAC systems. All right. That's a mouthful, but basically what it means is if you have a unitary system, a packaged rooftop unit, you have a furnace with a cooling coil, you have a heat pump, you have a split system, something that's unitary, they want to be able to evaluate the system, and how that's the system, not just the piece of equipment, but that is kind of the core of the system, is those pieces of unitary equipment. And they want to be able to evaluate that and give that a score so you can have an educated conversation with an owner to say, hey, your system's not performing. You might want to take a little bit of a idea. You want to take a look at it. Or you want me to take a look at it, rather. And also to kind of monitor year over year whether or not their systems are getting better. Rarely getting better, or if they're getting worse drastically, if something happened that they haven't been able to identify. And a lot of that can happen for various reasons. And you know that the deterioration effects really affects, not only the occupants, it affects the O&M staff, who really are never at a loss for opportunities to stay busy. It's also impacts the organizational mission of companies. If you think about, everywhere from hospitals to educational facilities, having that comfort, and we talked about this the other episode. If you haven't listened to it, take a look at the episode about an article summary that I read about human performance. So it really does impact human performance. It goes way beyond the actual efficiency or the rating or the score. But it's bigger. It's a bigger issue than that. But the score allows you to have that conversation with the owner. So typically, why aren't systems performing? It can be one of the usual suspects. It could be something with the O&M staff, like not changing filters. or not keeping up with the required maintenance. Maybe that's their fault. Maybe it isn't. Maybe they're just too busy and they just don't get to specific pieces of equipment. Maybe they're hard to get to. That's the design engineer. They're to blame. Maybe the design engineer didn't really factor in a couple of things about the system. Maybe they oversized the system. Maybe that's why it's underperforming. Maybe it was the mechanical contractor. Maybe they put it in poorly. Maybe they didn't ask a question when they should. Maybe it was the occupants that really are starting to affect the performance of the system for one reason or another. There's a lot of different people. You could point the finger at just about anybody that was involved with the built environment. But the one nice thing about this seminar was it really was based on a case study that they did on about 800 different field-installed systems. So let me explain a little bit about what the scoring actually is. This is of the 221 is centered around the system, not necessarily the piece of equipment. But what it is it's the performance of the installed system. They take some of the outlets, the enthalpy at the outlets of the supply outlets, the return inlets. They calculate the differential in the enthalpy, and they'll calculate the airflow for the system, and they can use that to come up with a capacity that's actually being seen as they go. They'll take the system and they'll put it into full cooling mode before they do this, and that's the kind of the condition that they're looking to test this at. With some pretty standard pretty standard tools. So ultimately, the scoring is whatever the enthalpy that they've actually tested, and that'll be divided by the rated capacity of the unit, what the unit should be putting out at design conditions. And there's a couple different factors that you can play with, but in general, that's exactly what it is. So obviously, 100%, it's performing at rated capacity, and at 50%, it's performing at half its rated capacity. Now, a lot of the homes, and actually, let me just state this, in the session, homes are typically below 60%. So they're performing well below what their rated capacity is. Code compliance systems on the commercial side would perform in the low 60s. So that was generally what they're seeing. Now, this test really doesn't take too long, anywhere from 45 minutes to 90 minutes, depending on the size of it. The commercial installations, obviously, taking a look at or taking a longer look at their systems. And generally speaking, the accuracy of the of what they're doing here is kind of plus or minus 13%. So that is some of the data. So let's take a look at what the actual case study was. The case study, this was done for rooftop units, package rooftop split systems, mostly in California. They did have a data set of 819 that were tested, and they actually, only 400 of those were actually modified and then tested after that. So half of what went into the study actually they actually did something and changed it. So for the systems, and we mentioned that 60%, the low 60s, that was not even close to what they actually saw out there. Typically, on average, it was like 48% is what they tested in at, all 819 of them. And when they did those changes on those 400, 83%, that was the new documented output. So that was very drastic. That was like a 73% improvement. I mean, obviously, if you don't subtract 40 or don't subtract 48 from 83 to get that improvement, because it's a little bit skewed on what was actually going in there. But I believe the study is accurate, so 73% improvement on the systems that were actually changed. So it was greatly improved. Now, 50% of that was from the equipment, and another 50% was from the system, whether it be ductwork or whatnot. Understanding that if you change the ductwork, sometimes the system is working better. So that 50% system, that might actually be higher if you were to kind of parse that out. So what actually affects this number from this study? Well, they identified the affected measures of performance, and basically improper airflow was one of them. Restricted airflow. So there's a lot of airflow. It was a lot of there wasn't a lot of airflow. Low airflow was a big concern. There was duct losses, leakage, thermal losses because of insulation or the lack thereof, and refrigeration cycle faults. So whether the charge was low, too high, faulty thermal expansion valve, or a bad compressor. Interesting to note, the things that didn't really affect the study too much, or didn't affect that score, that rating, was any sort of outside air issues, whether the ventilation was too high, too low, or whether there was a problem with the economizer. Also, the schedule and the temperature was not an issue. That is, and I guess if you take a step back, anybody who's involved with commissioning understands that when you test a piece of equipment, that's kind of a snapshot. So they're taking it to the max, taking a snapshot, and that's what the performance is. But when you get into schedule, when you get into the temperature controls, setbacks, things like that, that does affect the energy efficiency and the energy performance. It certainly does affect the comfort, but it does not affect this rating of the piece of equipment and the system. So important, yes. Part of the score, or affects the score, no. So just something interesting to note. So when they took a look at what were the top issues that they had, there was a lot of, number one, top four were, number one was the equipment enthalpy change. Basically, you're talking the evaporator coil. A lot of these had to deal with airflow, which was actually number 4, fan airflow. Number 2 was supply duct leakage, and number 3 was equipment temperature change. So those were and 4 was the fan airflow. Those were the top 4 items. So realistically, some of the repairs to address these top 4 issues, when you look at the blower coil, obviously clean the coils, clean the blowers, replace the filters. This is pretty basic, but it's something that you have to do to maintain performance. If you don't, it will constantly drag down. I mean, if you just replace the filters and don't do anything about the coil or cleaning the blower, or adjusting the belts, replacing and adjusting the belts is also another item. If they're slipping, if there's some slippage, if you can, if they loosen up just a little bit, that definitely affects some of the fan energy and the efficiencies of the system. Adjusting the fan speed, another one that they identified. All of these, if you just identify one thing, if you have in your maintenance program just one of these items, you might be missing a considerable amount to be able to fix. Obviously, taking a look at the refrigeration charge, looking at the combustion diagnostics, whether your combustion efficiency is right, whether or not you have enough, enough air in the system. Also, leakage locations, taking a look at duct sealings, or duct sealant. So the one thing, a little tip that they had is that a lot of that was, if you're going to do duct sealing, with tape or sealant or what have you, start with the highest duct static that you have, and then move on to the lower duct static. And generally speaking, that means start at the equipment and work your way down to the diffuser. So that was kind of one of their tips that they had for the audience. So last little bit that I will leave you with is the one thing they did say: if you're going to replace a piece of equipment, go ahead and test it. Go ahead and test it out using this test method, and take a look and make sure that you're not putting brand new equipment into a bad situation. If your ductwork is really leaky and you have a piece of equipment that's going bad, maybe it's not that piece of equipment's fault. Maybe it's the system. Maybe you need to take a look at that, and knowing that, as you're going in to the purchase of a new piece of equipment, is going to kind of save you a lot of headache. It's going to know what you need to do to your system to get it up to par, to be able to perform that way. So, all right. So that's my session summary today. Thanks so much for listening. I hope this is helpful. If you know anybody who's looking for more information on this topic, consider passing this along. If you're not a subscriber, consider joining the community over at HVAC360.com for some more weekly goodness. And the last two asks is I'd be greatly honored if you left me a rating and review on Apple Podcasts. And if you flip over to YouTube, subscribe. I need a bunch of people to subscribe to that to be able to offer more to you. So, that's a wrap for this episode of HVAC 360. I'm Matt Nelson, helping you be the best and the brightest in the field of HVAC. And as always, know what you build and share what you know.